Alright, the question says, in the diagram, ABC is a right angle triangle on a horizontal ground. And where is it? This is a right angle triangle. This is the horizontal ground. This, we have the side here. Can you see it? It's at the horizontal ground. And it's actually a right angle triangle. It is boldly written here. This one is showing that it's a right angle triangle. Right? And line AD is vertical tower. So line AD, this is a vertical tower. So this is the line AD we have here. It's a vertical tower. BAC is 90 degrees. So angle BAC is 90 degrees. As usual, we know that the angle is located on the letter at the center, which is angle A. That means this angle is also 90 degrees. Can you see? Then angle ACB is 35 degrees. So angle ACB, B, of course, the angle will be on angle C. This is the 35 degrees, right? Then angle ABD is 52 degrees. Angle ABD, that means the angle is on angle B, right? So it's 52 degrees. Here's it. Line BC is 66 meters. This is it. Find correct to two decimal places, the height of the tower, and two, the angle of elevation of the top of the tower. So how are we going to go about this? We know that this diagram is made up of three triangles, right? So the first one is here. This is A, then this is B, and this is C. So in drawing this triangle now, it's very important to know that if we are going to first solve the questions, we should calculate the height of the tower, and the height of the tower is line what AD. And in order for us to calculate the height of this tower, we need to find the side of the triangles of B or the side of the triangle C. That's the base. So we need to find this line, or we need to find this line, because it will help us using this triangle C or triangle B to get the height of AD. So how are we going to do? That means the first thing to do, we have to use the horizontal right angle triangle, which is triangle A, in order to get this side. Why? Because if you draw the right angle triangle A, we're going to have something like this. So we're going to have something like this. So in labeling this right angle triangle, we know that this place will be our A, right? This A. Then our B will be up here. And finally our C will be here. So if you will label it this way, we are aware that the right angle is always facing the hypotenuse. So that means this is the hypotenuse, line BC. So that means our hypotenuse is here, 66 meters, right? So 66 meters. Can you see? Then, in order to calculate the height of the tower, we will have to find this side, or this side. And finding those side, we are aware that BA is here and our AC is here, right? So that is what we're going to calculate. So it's very possible for us to calculate, because we should know that this C, this angle 35 is going to be here. This plane will be 35 degrees. So with this, it's very possible for us to calculate either line AB or line AC. So let's calculate it and see. All right, drawing the right angle triangle now, we're going to have something like this. We have A, B, C. A, B, and C. Remember that our hypotenuse is 66 meters and the angle here is 35 degrees, right? So now the first thing to do is for us to calculate line AB. This is line AB here, right? So let's calculate line AB and C. Of course, using trigonometry, the cheat of SOHCAHTOA, right? We have, and what is this SOHCAHTOA trying to say? Of course, we know that this cheat SOHCAHTOA means that sine is equal to opposite all over hypotenuse, and cos is equal to adjacent over hypotenuse, and lastly tan is equal to opposite all over adjacent. So now it's left for us to know what we are looking for. So what we are looking for and what we already have will help us to detect whether to use sine, cosine, or tan. Of course, we know that we are looking for line AB and our hypotenuse has been given. So that means we're going to look for relationship between hypotenuse and the opposite, because this is the opposite, right? So we're going to look for relationship between opposite and hypotenuse. And what's the relationship between opposite and hypotenuse? Of course, if you check it, opposite and hypotenuse is sine. Can you see? Opposite over hypotenuse. So we're going to use sine in calculating line AB. So we're going to say for line AB. So for line AB now, we're going to say that sine 35, right? Because we're going to use this trigonometry ratio, which is sine. So we say sine, which is the angle sine 35, is equal to our opposite. And what is our opposite? Our opposite is line AB. So we say line AB all over our hypotenuse, and our hypotenuse is what? 66 meters. So we're going to write 66 meters. 66. So what we're going to do? We cross multiply. If we cross multiply, we're going to have that line AB will multiply by 1. So we have line AB times 1 is same thing as AB. So we have line AB is equal to 66 sine 35. You see? So this is equal to 66 times, what is sine 35? Sine 35 is equals to 0.5736, right? So we're going to have 0.5736. So multiply by 66 times 66, we're going to have 37.856. Line AB is equal to 37.856. We say line AB is equal to 37.856 meters. So this is our line AB, 37.85 meters, right? 856 meters. So since we've gotten that, we know that this line AB, which is this place, right? It will be 66. All right. The next thing we may like to do is to find line AC. So for line AC now, because it's going to help us. So for line AC now, we're going to see the relationship, check the relationship between adjacent, because this is the adjacent, right? Adjacent and hypotenuse. We can still use the hypotenuse. So what's the relationship between adjacent and hypotenuse? Let's check our trigonometry ratio. Adjacent and hypotenuse is actually cos. Can you see? Adjacent over hypotenuse. So we're going to use cos 35. So we say cos 35 is equal to, adjacent is what? Our AC, right? Because this is AC, this line. So it's going to be AC, line AC, all over. What is our hypotenuse? Is 66 as usual. So we have 66. So cross multiplying now. By the time we cross multiply, we're going to have line AC is equals to 66 cos 35, because this one balanced one with one here. This one is going to cross multiply this. So we have 66 cos 35. Right? So what is cos 35? This one is going to be 66 times, so cos 35 is 0.8191. 0.8191. So times 66 is 54.06. So AC, or line AC, so 54.06 meters. So this is our line AC. So let's go back to the diagram and check. So now we've gotten this place and we've gotten this place. So it will be very, very easy for us now to get our AD. Why? Because now we know that this B is having a base and is having the height here, right? So AD will be the height, because there's 52 degrees here. It will be very, very easy for us. So let's construct the angle first. We construct the angle, we're going to have something like this. And this place, which is our B, and this will be our D, and our A will be here. So if that's the case, we know that this will be 52 degrees. Then Remember, we've calculated our BA, which or AB, we've calculated as what? 37.856. So we've already calculated AB. So for us to get the height of the tower is as good as calculating what? Our line AD, right? Right, so representing it in our diagram, we're going to have something like this. So this is our B, this will be our A, and this will be our D. Remember, the angle is 52 degrees, right? And we've already calculated that line BA or AB is 37.856, right? So we're going to calculate AD, which is the height of our tower. So we're going to say I, that's our first question, which will be line AD. So for line AD now, so our unknown now will be line AD, which is our opposite. This will be the opposite, and this will be the adjacent, right? So we're going to see the relationship between the opposite and adjacent because the adjacent has been given. We've calculated our adjacent already. So what is the relationship between adjacent and opposite? The relationship between adjacent and opposite is tan. We're going to use tan. So in using tan now, we're going to say tan 52 because that's our angle is equals to tan is what? Opposite over adjacent. So what's our opposite? Our opposite is line AD. All over adjacent, our adjacent is now 37.856, right? So if you cross multiply now, balance this with 1 and cross multiply, we're going to have that our line AD is equals to 50, is equals to 37.856 tan 52. So this one is going to give us that our line AD is equals to 37.856 times, so let's find tan 52, is 1.2799. 1.2799, right? So multiply it now by 37.856 is 48.45 meters. So that's the height of our towers. And AD is equals to 48.45, 48.45 meters. So remember that our question says that we should leave it in what? We should correct our answer to 2 decimal places, right? We should correct our answers to 2 decimal places. In 2 decimal places, it will be what? 48.45 because this is 2 decimal places. So we've answered the first question. So the second says that we should calculate the angle of elevation of the top of the towers. So before doing that, let us write all the side we've calculated so that we'll know what we have left, right? We have calculated that we know that this place is 66 meters, right? And we have calculated our AB as 37.856. So write 37.856 here. Our AC, we've calculated it to be 54.06. And we've calculated our AD, that's the height of the tower, as 48.45. So we have 48.45 meters here. So these are the side we've calculated. So the next thing we are to calculate the angle of elevation, right? That's the question. The question says we should calculate the angle of elevation of the top of the towers from C. That means our point of focus is going to be what? This C, right? So how are we going to do? We are going to use what we've already calculated to get what we want. So how are we going to do it? Let's bring out this using the triangle C. The triangle C now will help us in doing that. We're going to have something like this. So triangle C. So this one is going to be D here, right? This one is going to be C, and this place is going to be A. Remember that AD has been calculated as 48.45. Here's it. Then our AC is 54.06. Now, with this, we will be able to calculate this angle, because that's what we're going to do first. If we're able to calculate this angle, right, it will be easier for us, because even from our question we know that we already have this angle as 35 degrees. So this one is 35 degrees, and we already know that this angle was given as 52, right? So now if we're able to calculate this angle and add it to this 35 degrees, we'll know the total angle there. So let's calculate this small angle here, that's this theta. So how are we going to calculate it? We're going to use the relationship between opposite and adjacent. It's going to help us. So what's the relationship between opposite and adjacent? So opposite and adjacent is actually going to be tan, right? We're going to make use of tan. So tan is opposite over adjacent. So we're going to say tan theta, since we don't know what the angle, right, is equals to opposite over adjacent. So what is our opposite? Our opposite is 48.45. All our adjacent is what? 54.06. Cross multiply, we're going to have that 54 times tan theta, right? Because we're going to cross multiply, this will multiply by this and this will multiply by 1. So we're going to have that 54.06 times tan theta is, we have tan theta here is equals to 48.45. So remember we're looking for tan theta. We divide both sides by what? 50.06. So this cancels this 54.06. We'll be left with what? Tan theta is equal to 48.45 all over 54.06. Let's divide it and say 48.45 divided by 54.06. 48.45 divided by 54.06. So the answer is 0.8962. So we're going to have that tan theta now is equals to 0.8962. 8962, right? Remember that we're looking for theta, not tan theta. So we divide both sides by tan. If we divide both sides by tan, we're going to have theta. Using law of indices now, you know that it's going to be equals to tan inverse of 0.8962. So what's the meaning of tan inverse? We're going to use the calculator. That's shift tan. That's tan inverse of 0.8962. So we're going to have 41.8667. We're going to have 41.86667. So our theta is 41.8667 degrees. Now we've gotten this angle. This angle here is 41.8667, right? So since we are able to get that, by the time we add these two triangle now, we'll be able to get the total angle. So we're going to say what? The total angle now, total C, angle C, right? Total angle C is going to be the angle we've calculated as 41.8667 plus our 35 degrees. So we're going to say 41.8667 plus 35. So this one is going to give us the total angle as what? Plus 35 degrees, right? Is 76.8667. So remember, in two decimal places, it's going to be what? 76.87, right? We round it up. So we're going to have 76.87 degrees in two decimal places. So this is the angle of elevation from the top of the torus. So that is our answer for the second part.